Hello, everybody. This is our last video on increasing and decreasing functions. There's a lot of new vocabulary here. The last part is just about monotonicity. That just means that some functions, in particular exponential functions, are either increasing or decreasing for all x belongs to real. In other words, they only go one way. They only increase or only decrease. And so sometimes we call them monotone increasing or monotone decreasing. Here's a function that's monotone increasing because it's always getting bigger, whereas this is a function that is monotone decreasing because the y values are always getting smaller. So just for example, what would that look like if you saw it? If we were asked to find the intervals where f of x is increasing or decreasing, and we get a function like this, okay, we're going to follow our same procedure. We're going to take the derivative, set it equal to 0, and solve for x, and draw a sign diagram. When I take the derivative of this function, I get e to the negative x times negative 1. And when I set that equal to 0, I see that it's impossible. I can't set this equal to 0. Okay, there's no value of x that will make negative e to the negative x equal to 0, so therefore there's no turning points. I still draw my sign diagram with my endpoints, negative infinity and infinity, my derivative on top, and my function values on the bottom. And it doesn't matter what value I pick. Whatever value I plug in for x, my function's always going to be negative. My derivative is always going to be negative. Okay? So if my derivative is always negative, then my function's always decreasing, and my function, we say, is decreasing for all x belongs to real, or is monotone decreasing. The ln function has a similar situation, okay, where it's not going to have a lot of turning points. Notice that when I take the derivative of ln x, the derivative is 1 over x, which means there's a vertical asymptote when x is equal to 0. Okay, and also this function is only defined when x is greater than 0. So if I set it equal to 0, my derivative, I find that that's not possible. Okay, which again means I can draw my sign diagram, but it doesn't matter what number I plug in. I could plug in a 10, I could plug in 15, I could plug in a million. Ln of that number is always going to be a positive value, so my function's always going to be increasing. Okay. And that's it for monotonicity. Thank you.